Example number 2. We have the function f of x equal x cubed minus x, and we want to find the formula for f prime of x. The formula for f prime of x is the limit as x approaches to 0 of f of x plus h minus f of x divided by h. So we have the function f of x is x cubed minus 1, so we will plug in x plus h. So we get x plus h cubed minus x plus h, and then minus x cubed minus x over h. And we need to take the limit as h approaches to 0. We will expand this and on the top, and it's a little bit messy, but it will work out at the end. So we know the formula for a plus b to the third power is a to the third power plus 3a squared b plus 3ab squared plus b cubed. Okay, so we will use that for x plus h cubed. So x cubed plus 3x squared h plus 3x h squared plus x cubed minus x minus h, and then minus x cubed plus x over h. Now we will cancel the margin terms. So we have x cubed and x cubed. We have x and x. So that's all we have left, and you see that the terms that we have left have the h in common. So you can factor out the h on the top, so you get 3x squared h plus 3xh squared plus x cubed minus h divided by h. So cancel the h, and now we will plug in the h equal to 0. Then this one have no h in here, right? So we have 3x squared, and we have this one is 1. The h right here is just h after we factor out the h and the h squared. Okay, so if h equal to 0, that means that these terms will be gone and this term will be gone. So then we will have 3x squared minus 1 left. Then in part B, they said that we will use this formula comparing the graph of f and f prime. So we have the graph of f and f1, f prime on the right hand side, and now let's notice that right here at this yellow point, we have the tangent line is like this. It's the horizontal. So the slope will be 0 and 0 at those points. So I'm going to call this point is A, and this point is the point B. Okay, so the point A is about like a half, negative 0.5, and the point B is also like about positive 0.5. So we have A prime in here and B prime here. So from the point A to B, what do we see is that A go to B is going down. If we draw the tangent line will go this way, which is the slope is negative. So m is negative. If the slope is negative, it means the f prime will be below the x-axis. So that's why the connection from A prime to B prime is below the x-axis. Now let's look at this interval from the left side of A. the ring interval. So if we draw the tangent line go like this, right? So the tangent line is the slope of those tangent lines are positive, and also the slope of those tangent lines on the ring part on the right side of B, also the slope is positive also because the lines go like this, right? So we have both of them are positive, so that's why the outside of A prime and B prime it will be above the x-axis. So that's why we have this side and that side, they are both above the x-axis. Example number 3, we have the function f of x equals square root of x. We want to find the derivative of the function f. So formula is f prime of x equal limit as h approaches to 0 of f of x plus h minus f of x divided by h. Now let's plug in the x plus h into the function, so we will get square root of x plus h minus square root of x divided by h. So we will rationalize the denominator, the numerator, because if we plug in the h right now, we will get undefined. So we will do some algebra to fix this, so it will multiply by the conjugate. So square root of x plus h plus square root of x divided by square root of x plus h plus square root of x. So on the top, we will have x plus h square root, so it will become x plus h only, and minus square root of x squared, and it will become x. In the bottom, we have h, and then x plus h plus square root of x. For the top, we will open parentheses and combine like terms, so the x will cancel out, so we're left with h only. In the bottom, we have the h, if you notice. Then we will cancel. So what do we have left is h approach to 0 of 1 over square root of x plus h plus square root of x. And now we can plug in the h equal to 0. Then we have 1 over square root of x plus square root of x. And that will become 2 square root of x. In the problem also asks us to state the domain of a prime. So the domain of the square root is x greater than or equal to 0. However, this square root is in the denominator. It cannot be 0, otherwise we will get undefined. So we just take the x greater than 0 only. If you want to write in the interval notation, that would be from 0 to infinity.